Hello everyone, this is the Algebra 2 end of course review video for chapter 4a, and we will be talking about rational exponents and radical functions, mostly square root and cube root functions. So this review is split up into two different parts. You have the rational exponents part, and then you have radical functions. So let's talk about rational exponents. If you notice, this is kind of like a generic pattern right here. Anytime you have a root, you can rewrite it. Instead of using a radical symbol, you can use a fraction exponent. That's what's called rational. So whatever root this is needs to be the denominator of the fraction exponent. So if you see a square root, that is to the power 1/2. Cube root is to the power 1/3. And if there is another power on the x or whatever that is right here, it's going to be the numerator when you change it. You're also going to need to be able to use all of these power rules for exponents. A lot of this is from Algebra 1 and we practiced it. So basically it says that if you multiply the same base, you add the exponents. If you divide the same base, you subtract the exponents. If you have a power to a power situation, you multiply your exponents. And if you have a negative exponent, you take the base and you write it as a base in the denominator with a positive exponent. If you are trying to simplify a radical, your calculator, if you have access to it, will simplify a square root. But if you wanted to simplify a cube root or anything higher than that, you would need to split the number up into those cube roots so you can simplify it. Let me go over here so I can show you what I'm talking about. So let's say I want to do the cube root of 16. Now 16 is not a cube root, but I do know that 3 to the power of 3 is 27. Actually, let me go backwards. I meant 2 to the power of 3, that is equal to 8. So 8 will divide into 16, so I can rewrite that into 8 times 2. And you can separate it. You can say the cube root of 8 is 2, and then your leftover, of course, would be the cube root of 2. A couple of other properties over here would be, now I just used this one right here, but if you were dividing, it's the same thing. So you can take them and separate them into a numerator and denominator, and then take whatever root it is. However, it can help you simplify. Moving on, let's talk about the parent function for a square root function. If you notice, this is a limited domain. It starts at 0 and it approaches positive infinity, so you can write it as an inequality by saying x is greater than or equal to 0. Likewise, if you were looking at the range, that would also start at 0 and it goes up. So instead of thinking it goes to the right, it actually also goes up as well. So it is going to be y greater than or equal to 0. The cube root function, on the other hand, has no limitations. It goes forever from negative infinity to positive infinity. So the domain is not restricted, and the range is also not restricted. It continues to go down and continues to go up forever. So both the domain and the range would be all real numbers in this case. The transformations for radicals are the same as previous chapters. If you add and subtract to x, it's left and right. Opposite, though, what you think it's going to be. If you add to the function, it'll go up. Subtract, it'll go down. If you multiply by a -1 to either the x or the function itself, it will reflect. And then if you multiply to the entire function, it will vertically stretch or shrink it. If you multiply only to the x, it will horizontally stretch or shrink. And then the last thing here is make sure that you get your priorities in the right order when you are solving for radicals. So if you have a square root or a cube root equation, the number one priority is to isolate the radical. You've got to get the square root and the cube root by itself. That's step number 1. Once you get it by itself, you've got to get rid of that root. So either you're going to square both sides or cube both sides, but that is the steps. Step 1 and step 2. And at the very end, of course, check your solution. If you have a square root equation at the very end of the square root, you might wind up with something that's extraneous, because extraneous is a fake solution. You're never going to have an extraneous solution if it is a cube root, and the reason why you have an extraneous solution for a square root is that you've got all of this area over here that does not exist. So sometimes when you square both sides, you create a fake solution called an extraneous solution. Now let's take a look at some practice problems. These top two are ones that you are not allowed to use calculator on. So what you've got to do is you've got to recognize that we are using one of our exponent rules. If you are multiplying the same base, you are supposed to add the exponents. So you've got 1 plus 1 plus 1 plus 1 plus 1 plus 1 gives you x to the power of 6. So basically it's like add the exponents, that's going to be your final exponent. So now what it wants you to do here is figure out what are two expressions that are equal to x to the power of 1. So what you have to do is got to make sure that these are equal to 1. That's too many 1/3. So it's actually 6 over 3 when you add them all together. That is not equal to 1, that's equal to 2. 1/3 plus 1/3 plus 1/3 is 1, so that is one of your answers. And then if you add 6 1/6s together, that is 6 over 6, which is 1, which means the other two don't work. And if you notice, when you add them together, they will be negative, which is not what they're asking you to find. Second question, you need to absolutely follow the strict order of steps. So the first thing you want to do is get the radical isolated. So you have to add 9 first. Once you get that radical isolated, you have to square both sides. And that will undo the square root. Subtract 5. And you wind up with 116. Now, this isn't going to be extraneous because when you check it, if you plug in 116 into your original equation, this is like 121. That's 11 minus 9, and 11 minus 9 is 2, which equals the other side. One thing that you need to look out for when you are solving these types of equations is the squaring of a binomial. A lot of people think that this is going to be equal to x squared plus 9. This is incorrect. This is one of the top 5 most missed mistakes of Algebra 1. So what we're going to do is we're going to actually do this correctly by using the area model. So x plus 3 times x plus 3. Whenever you're multiplying, just draw you a little rectangle. It'll save you from a lot of errors. So we're going to go ahead and add the like terms together. 3x plus 3x gives you 6x. And see how that's very different than what we had before? So if you square a binomial, that's a 2 by 2. You're going to have 4 operations and add the 2 in the middle. Some of your questions on your EOC may ask you about operations. So if you wanted to try to solve a cube root equation, the first thing you're going to do is you're going to multiply both sides by 5. And it shows you here what you get after that first step. Then the next thing is to immediately get rid of the cube root. So you have to raise both sides to the power of 3. So in that case, you can eliminate A and you can eliminate B. At the very end, you wind up with x minus 18. But you've got to add 18 to both sides, which gives you your final answer of 143, which is choice D. All right, so on this next one over here, what we're trying to do is we are comparing a table and a graph. So it says student 1 correctly creates a table for f of x, while the student 2 correctly graphs f of x on a coordinate plane. So this is the same thing, it's just they have like, you know, very different visualizations because one's just coordinates, the other one is like what it looks like. So we're asking for which one, let's see, which one is true. So it says a table for f of x reveals a y-intercept. So if you look at this table right here, there is no y-intercept at 0, 5. So this is absolutely out. B says the table for f of x reveals a y-intercept. No, it does not. It reveals an x-intercept at 5, 0. Yes, this is an x-intercept, so it's definitely could be C or D, while the graph reveals a y-intercept. Now, the y-intercept on the graph is right here, and it's going to have a coordinate of 0, -1. And it looks like C is in the wrong order, so it has to be D. So just read it and double check. Your end of course will definitely have some short answers, and I know that you're not used to it on your benchmark, but it says that you will have some short answers. You're going to have some drag and drop, multiple select, so just be ready for that. So this is an example of making sure that you have your cube root isolated, and then you have to raise, I did it the wrong way, boop, boop. That should be power of 3, not squared. But it is still -8, so I got that part right. Then we're going to add 3 to both sides. So I want it with -5. If you have time, always double check and just make sure that you're getting everything right. Okay, this is going to be the cube root of -8. You are allowed to take the cube root of a negative number. So yes, left side is equal to the right, so everything checks out. Okay, so last one says, what are the solutions to the equation? And then it says check for extraneous solutions. Extraneous means that it is a solution that has been found by solving. It's not some random number. You have to solve it and kind of get that as a result. But when you check it, it doesn't work. So let's see if this one actually gives us a fake solution. So this is already isolated. If it's isolated, you're going to go ahead and get rid of the square root. So we're going to square both sides. When I do that, this is quadratic. If this is quadratic, you want to make it equal to 0. The easiest thing to do is move everything to the side of the quadratic term. And then we're going to factor it if possible. This one's going to use +3, -2 as our factors. Remember, factors aren't solutions. Oh, I don't need to put it equal to 0. So I'm just going to do this in my head. So it'll be -3 and +2. These are solutions, but that doesn't mean that they are going to work. So what I'm going to do is I'm going to plug in -3 and see if this works. Okay, over here on this side, I wound up with the square root of -3 equals -3. Absolutely not. So that is what we call an extraneous solution. Now, if I come over here and I plug in a 2, yeah, you see how that works? So this one works. So there's only one real solution to this one and one extraneous solution. Let me know if you got any questions.